Hi, how are you, dear students? Today we will solve the first numerical of the challenge questions, AP Physics. The question says that a 5 gram bullet is fired horizontally into a 1.20 kg wooden block resting on a horizontal surface. The coefficient of kinetic friction between the block and the surface is 0.20. The bullet remains embedded in the block, which is observed to slide 0.3 meter along the surface before stopping. What was the initial speed of the bullet? So the bullet is just fired in a horizontal direction. We have to find the horizontal velocity of the bullet. Okay, we call the bullet as a first body, so we name it as v1x. Okay, this will be its horizontal velocity. We have to find it. Okay, its mass is given as 5 gram. We have to convert into kilogram, that is 0.05 kg. Okay, dividing by 1000. Okay, this is the mass of the second body. Okay, 1.2 kg, and it is at rest, so its velocity is 0. Okay, here its velocity is 0. Therefore its momentum and kinetic energy here will be 0. Okay, finally, okay, the this is the situation which is I have explained before. Okay, this is what happens before after the collision. Okay, the bullet remain embedded, mean remain inside the block. Okay, okay, so the bullet will impart its momentum. Okay, after that the block will move in a horizontal direction, and it will cover a distance of 0.31 meter, 0.31 meter horizontal direction. Okay, the block will eventually, at last, the block will stop here. Okay, here its velocity I call it vf, final velocity will be 0. In this situation the block will move in a horizontal direction. Okay, this is the common velocity of the bullet and the block system, so I call is capital V. Okay, capital V, here its velocity is was 0, eventually it stop. I call it vf is equal to 0. Okay, so starting from starting this problem with the help of law of conservation of linear momentum. Okay, according to linear momentum, when there is no impulse acting on the body, then the linear momentum remain conserved. Okay, so the force, external force is 0, so we call that f. When f this become force becomes 0, external force, there is no external force, then this means that delta p will be 0. This means that momentum remain conserved, momentum remain constant. This is so it implies that momentum individually in x direction and in y direction it will be conserved. So pix, initial momentum in x direction, is equal to initial final momentum in the x direction. Okay. Hmm. What is the initial momentum of the block and bullet system? So momentum of the bullet will be equal to m1 v1x, and the bullet, sorry, the initially the block was at rest, so its momentum is 0. Afterward, the velocity of the bullet and the block, uh, they will moving with a common velocity. Okay, so momentum will become m1 m2 multiplied by v, the common velocity. Okay, from this equation we can find the velocity of the bullet v1x. Okay, it will be equal to m1 m2 divided by uh, this is m1. Okay, it will be divided. Okay, and this will be the velocity, the common velocity. Okay, so in this equation we are, all quantity are known, but the common velocity are unknown. Okay, how can we find? We can find out by introducing another concept of work energy theorem. What happens here? Okay, all the kinetic energy of this block, okay, is consumed by due to the work done. Okay, the work done against the friction, the work done against the friction, because here the kinetic energy, let's suppose I denote with a k1, and here kinetic energy k2. Okay, here eventually it comes to rest, so kinetic energy at this stage will be 0. Okay, due to the rough surface, the force, the kinetic friction, okay, will do work. Okay, that will be against the motion of the body, which therefore the body stops. So according to work energy theorem, we say that work done against the friction, work F for friction, will B equal to the change in kinetic energy. How much kinetic energy change? It was changed due to the work against the friction. Okay, what is work done? Here the work done is equal to, we know that Fk and dot product of force and displacement. Okay, Fk s cos theta. What is the angle between the kinetic friction? Or let's say indicate this with the help of diagram. In the diagram, we see that the block, okay, the rough surface will exert force in the opposite direction. Okay, when the blocks come, okay, the kinetic friction will be the force due to kinetic friction will be in this direction. Okay, the rough surface will be exerting force in opposite direction. And what was the direction of the displacement? Displacement was in forward direction. Okay, s was in forward direction, so the angle become 180 degree. The two vector become anti-parallel. Okay, it means that cos 180 degree minus 1, it will be fks. Okay, this will be the work done against friction, wf. Okay, so work done will be equal to minus Fks. Okay, and what will be kinetic energy here? Kinetic energy was equal to K2 minus final kinetic energy minus initial kinetic energy. But eventually the bar block stops, so this was 0. Okay, it means that, okay, it means that the work done Fks will be equal to minus K. The negative sign will cancel with each other. Okay, this negative sign will be cancel out. Okay, so we are left with what? Only this is K1. Okay, this is K1. So it means that Fk kinetic work done will be equal to K1. What is the value of Fk? Fk, you know that kinetic friction is equal to mu K n, where n is equal to mg. So mq, the normal reaction, is equal to always the weight of the body. Okay, mg, m time acceleration due to gravity, n was equal to mg. We know that. How much normal reaction action on the surface is equal to the weight. Okay, for example, let's suppose we can indicate this thing here. Okay, the normal reaction acts in upward direction while the weight of the body acts in the horizontal direction, so they are balancing each other. Okay, this is the normal reaction. I denoted it n, and the weight is downward mg. Okay, so what will be value? What will be the value? So this equation will come to be mu k mg mgs. Okay, 1 over 2 m, okay, m v square. Okay, okay, what was the mass of this? Okay, okay, this will be the m will be cancel out with each other. Okay, the mass of the combined mass. Okay, the combined mass of the, okay, this will be m. What is the m? Actually m is the combined mass of the uh, bullet and the block. Okay, that will be cancel out each other. Okay, mq mu k gs is equal to 1 over 2 v square. Okay, so v square will be equal to, we will, from this equation we can write directly that v taking square root also, that v will be equal to mu k 2 mu k gs. Okay, by putting all the values, we will be putting the values in this equation. 2 mu k was 0.20, and the value of g is 9.81. Okay, h was how much distance was covered? 0.31. Okay, putting all this value. Okay, okay, it will come out to be 0.9. Okay, 0.9. Okay, uh, oh, actually it will be, I think it will become 1.2. 10. Okay, the value will be like that, velocity will be meter per second. Okay, now we can put this value in the equation. Okay, v1x initially we have all call the in this equation. Okay, putting value in this equation, I call this equation as equation 1. Okay, putting value in equation 1, putting all the value in equation 1, you can find out that m1 was equal to how much? 0.00, okay, 5 plus m2 was equal to actually the mass of the block 1.20 divided by m1 0.005, and the velocity becomes 1.10. Okay, after putting all these value and calculating, I think you can easily find out the value. Okay, okay, thank you. You can calculate it out, okay, with the help of calculator.